example because we've used it before. Hopefully my graph will work. If not, I'll change it a little bit. All right, so the next page. Oh, that's actual practice. I can probably work with this graph here. All right, so let's see what all I can delete. Oh, not everything. Shoot. Let's try this and see if it works. That will probably work there. All right, so we go into a store. We want to buy honey buns and airheads. When I'm talking, I should be the only voice I hear, and I hear a bunch of voices. So I go into the store. I want to buy airheads and honey buns. I have $15, and I'm going to spend all $15. So you're spending $15. You're going to get airheads and honey buns. Honey buns, just to make the math easier, are $2. Airheads, again, are $1. So again, and that's not super unrealistic, depending on like what store. If you go to a convenience store, you're not cheap in convenience stores. I want to know what are some values. So again, I spend $15. Exactly. So I spend all $15 on the move. Tell me what I can buy. What combinations of airheads and honey buns I can buy. So can anybody tell me exactly what I buy right now? I'll give you enough information that it's for you to say, yeah, you bought this many airheads and this many honey buns. So did you hear what I said? Before you do that, can you tell me exactly what I bought? Can't, right? You have no idea. All you know is I spent $15. There's only one rule. The only rule is that I spent $15. And I buy airheads and honey buns, I guess you would say. That's not really involving any numbers you can create a rule with. You just know what you could have been buying anything. The rule really has to do with the fact that there's numbers. A rule would have to have numbers in it from a math standpoint to be considered a rule. So we know there's one rule. I have to spend exactly $15. So with that in mind, what can I buy? Yeah, it should be faster than this. Oh. That. And there's probably one here. I'm still waiting, by the way. Waiting on you. What can we buy? Again, you want phone time today while you work? Better start participating. That's a new rule in all the classes. Normally, you guys are good at it. Justin. Oh, I thought so. Like somebody sort of figured it out. If you have 50 and you're spending $15, honey buns are $2, airheads are $1. Give me a combination you could buy. We'll say that honey buns are the X. So I'm going to put it first. So honey buns, comma, airheads is the way the ordered pair looks. So 4 times 2 is 8. So we spend 8. How many airheads would we have to buy? Spend 15. So we have to get 7 airheads, right? So 4, 7 works. Again, I'll go ahead and label it now. If X is honey buns, then the X-axis has to be honey buns. Number of honey buns to be exact. So that's the X-axis. The X is honey buns, so the X-axis has to be honey buns. So that's one thing you need to make sure of. You'll never really have to create your own. Well, I don't think you'll ever have to create your own graph. airheads and number of. All right, so we'll put the numbers in a second. Give me another combination. So there's one. We're gonna do probably 4. What else? Oh, there's the bottom here. Ellen. So 5 times 2 would be 10. We still have $5, so we need 5 airheads. Oh. So again, if this is honey buns, first is honey buns, then airhead. 5 and honey buns are $2. So 5 times 2 that's $10. I still have $5 left over, which means I get 5 airheads for $1. What else? Give me one. Yep. And we can figure it out while you're thinking. So if you bought 7 of these, that'd be $14. So 1 airhead, right? All right. Now let's do one more. Who am I gonna call on for this one? Chris, give me one. So 3 times 2 would be 6. We'd have $9 left over. So 3 and 9. I'll write that down. So there's 4 combinations of airheads and honey buns we could buy. Do I want to make every single square a 1? Yeah, I guess I kind of have to. All right, so every single square is going to represent 1. Hopefully I have 15. Oh yeah, going up, I definitely have 15. So that'll work. Every single square is a 1. So I'm going to just plot these numbers now. So 4, 7. Oh, so this is the X and Y axis. So that's 0, 0 right there, that corner. I'm not showing any negative numbers because I can't buy a negative number of honey buns or a negative number of. So I can graph out all the possible solutions. Remember, a line is all the possible solutions. So this will be all the combinations of honey buns and airheads I could buy. Even though I only figured out 4 of them, when I do the line, it'll be all of the possible. So 3, 9 would be 3, 1, 2, 3, 4, 5, 6, 9. So there's 1. What do we have? 7 and 1. 1, 2, 3, 4, 5, 6, 7, and then 1. And they should all line up, or I did something wrong. Either I have a bad combination, or I put it in the wrong spot on the graph. Because it should be a straight line. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Looking pretty good so far. And then 4, 1, 2, 3, 4, 5, 6, 7. And that looks pretty good as far as those lining up. Feel pretty confident that we're doing everything correctly so far. Now we're going to connect all of those points. Oh, there we go. That's pretty good as far as that goes. We'll move it over a tiny bit just to try to make it perfect or more perfect. Clicked on the wrong thing. There we go. That's pretty good. Actually, these squares, I checked them one time. Those squares are not perfect squares. They look pretty close. My graph cannot be cool. So there we go. That's all the possible combinations, right? But you cannot tell me how many honey buns I bought. We said a long time ago, if you have 2 variables, but only 1 equation, you can't solve it. There's no way to solve it. That's why we graph. We can graph all the possible solutions, which is what we just did, every number on there. So what's one we didn't do? Let's see, did we do 6? So let's say this point right here. If I wanted to know a combination for, what if I wanted 6 honey buns, how many airheads? I would just count out 6 honey buns. 1, 2, 3, 4, 5, 6. Go up to the line, and that means 3 airheads. That line is every possible combination. But I still can't tell you exactly what I bought. Two variables, one equation, can't solve. But here's what we're getting into today. We're getting into what's called, this is your subject, so write this down. We're doing a system of equations. Write that down. That just means you have more than one equation. So instead of just one equation, we're actually going to have two equations that we can use to solve when we have two variables. And right now we have two variables, the number of airheads and the number of honey buns. So if I add a second rule, an equation is a rule. I have one rule that we have to spend $15. Now, though, I want to add in another rule, and I want to say, here's the rule number 2. You buy 8 total items. So not spelled correctly. I teach my. So the total of the airheads and honey buns you buy is 8. Now you can tell me exactly what I want. Because we now have two equations and two variables that we can solve. So I want you to tell me which one or what do we buy. You can tell me exactly now. Because of that second rule. Only one of those values on that line will total 8 items. We'll prove that in a second. Gabrielle, what did I buy? Gabrielle, what did I buy? You can tell me the exact number of honey buns and airheads now. You know I spent $15, which is all the points on that line. But you also now know I bought exactly 8 items, and only one point on that line is exactly 8 items. I'll give you a hint. We actually came up with it when we created them. Or the ones we had. Is that a total of 8? 5 plus 5. 5 plus 5. We bought 5 air. So again, if you're not understanding what I'm saying, I bought a total of 8 things. So when I add up how many honey buns I have, and when I add up how many airheads I have, add them together, that better be 8. 5 and 5 would have been 10 items. So that's not the answer. Which one? Yeah, 7 and 1, right? If I bought 7 honey buns, 1 airhead, that's 8 items. No other point adds up to 8. That adds up to 11. That adds up to 10. That adds up to 12. You could do that with every single point on that line. Nothing else will add up to 8. So again, this is your note. If you have 2 variables, but you have 2 equations, you can solve that. 2 variables, 1 equation, all you can do is graph, which is what we've been doing. Now that we're doing what's called a system of equations, we're going to have 2 equations. You can solve when you have 2 equations. So we're going to create, I'm going to create the, I guess that's, so here's the equation, the number of honey buns plus the number of airheads, because that's what X and Y are, is right here. The number of honey buns is X, number of airheads is Y. That has to total 8. And we can graph that also. I'm just going to graph that one real quick for you. I just need to come up with 2 combinations that make the left side equal the right. So I could do 4 and 4. 1, 2, 3, 4. 1, 2, 3, 4. So there, that's right there on the graph. I could do 6 and 2. So 1, 2, 3, 4, 5, 6. 1, 2. Wait, that's not right. Oh, yes. I could do 2 and 6. 2 and 6 would work. 2, 1, 2, 3, 4, 5, 6. So you'll notice all of those red dots are also lining up. So if I create a line going through those, here, I think. Oh, that's pretty good. Oh, that's pretty good. So let's make that line a different color, just so you can see it. Go with reds. It's already put red dots there. Oh, that's not the color. All right, so there, that line is red. And let's zoom in a little bit. So I've now graphed both rules. Remember, a rule is a requirement. I'm sorry, an equation is a rule. I've both graphed both equations. I've graphed those as rules. We have to do whatever the rules say. Notice anything about where they cross? Where they cross? It's the ordered pair where they cross. Do you think it's a coincidence that that was our answer? So the reason that's the answer, where they cross is the answer, because that's the number that meets both rules, right? It meets the $15 rule. If you do the math, we actually came up with it. That's how we created the line. If you do the math, that meets the rule that says we spend $15. If you do the math, it also meets the rule that says we buy 8 things. That's 8 things. So when you're doing systems, in all honesty, you're not going to do as much of what we just did on my quizzes. You'll see that I would almost guarantee on the final that the district makes up. We're going to just do more solving, either through graphing or through other ways that you'll learn. But I want you to understand what's happening is we're figuring out 2 different rules, 2 different equations, 2 different, in this case, 2 different lines that we graph. We won't always graph them. The solution is the one point, which there's not always a point that meets it. Like if I would have said he buys 10 total things, actually that would work. If I would have said he buys 20 total things, let's do that. Well, that wouldn't work. We can't buy 20 things and spend $15. We'd have to spend at least $20. So if those were our 2 rules, there'd be no solution. There is no solution where you buy 20 things and you spend $15. So the lines would never cross. This red line would be in a totally different place. It would never cross over the black line. So your answer would, for that, be there's no solution. It's not possible because the lines never cross. Or you technically you'd have a negative number, so the lines would cross, but if they cross in the negative, so it wouldn't make sense. Again, so where they meet is the point that meets both rules, or the short version of that, you need to write this down in your notes if you haven't written anything else, which most of you haven't. Where they cross, where the 2 lines cross, once you graph, that's your solution. I hope you at least understand a little bit. Oh my goodness, why are you guys all?
Morning.
Is this your fault?
I'm going through it. I'm rich. I scratched the car this morning.
And
Let me know. No, not with my boyfriend. I'm going through it by myself.
you need to have, do you guys need to come in for a couple counseling? I do couple counseling if you need. I do individual and couple.
What? No, I'm going through it with my life right now. Why did they almost get in an accident? Because look at this.
You do realize I teach.
Look at my socks tan.
Yeah.
This is so. They don't care. Class. This is so. Pretty sure they would rather us talk to you than you. I think they'll take it a quiz.
They're just as needy.
Yeah, and I need to do my.
So. Oh, you're so neat.
That's not true.
So neat.
That's a lot.
Mr. Gill, look at my boo-boo. Mr. Gill. Look at this. Mr. Gill, she did this. Mr. Gill. Guess what they called it? Actually, no. Mr. Gill, guess what the line is?
Where my dog? Where my
They-
back?
so
And my back hurts.
E
My
D.
throat is a little itchy.
Here you go. This is what I think of when I think of you guys. What I think of. I just wanted to see if you could figure it out.
No.
It's knee
No.
D. Knee D. That's what I think of when I think of you guys.
Exactly.
Oh, all right. So, we've done graphing before. I'm not gonna sit here and do a bunch of graphing. I want you guys to just work on it and I'll come around and help. Remember, you can create a table for any of them on that sheet. There's a lot of them where y is just already by itself and you can just do the y-intercept thing. So I'll probably do one of those in a minute. Actually, I'll just do one. Look at number 2. Oh, wait, no, I don't have number 2, I don't think. Look at. I don't have that. Look at, you pick. Which one of those do you want? Well, don't do 11 or 12 because that's where you have to plug in the values. We've already done that. 9 or 10. 9 is what I heard. All right. So look at 9. I'll zoom way in. Be able to, yeah, we still see that. So you're just graphing two lines on one graph. That's the only difference from what we did before when we graphed a line. That's it. We have a y all by itself in both equations. So that means we're going to be able to do the y-intercept and the rise and the run thing. The y-intercept is always the number by itself, not always the second thing. So don't just think that the second thing is always the y-intercept. It's the number by itself. So for both equations, there are my y-intercepts. The slope is always the number with the x. Technically, it's being multiplied times x, but you can just think of it as with the x. So my slope for that, and include any negative in front of it. You happen again. Yes, yeah, I guess that'd be yesterday. Different lesson, but people are not remembering that the number in front, I'm sorry, the sign in front of the number is the sign of the number, not the sign after it. This is not a negative 2 because there's a subtraction after it. It's the 4 that you would consider negative. Just remember that. The sign in front of the number is the sign of the number. So I'm going to graph these pretty quickly. I put a point, I'm doing the first one. I put a point on positive 4. That's my y-intercept. First step, point on the y-axis. Make sure you do the y-axis. Now I have to use this slope. I already have a rise and run, so I don't need to change that. Remember, if we don't have that, like over here, you'd have to say 2 over 1 is the rise over the run. I'm taking that slope right there and making it a fraction because it's not already a fraction. But over here, both slopes are fractions. So for this first one, which I'm going to do in red, I write, make the top number the negative number. So make the top number the negative number. That way you always go right first when you do the run. Never have to worry about which way you go for the run. So that's what I need to do to get the next point. Hopefully that stops. Okay. So from this point, I go right to positive number for your run means right. You should have all of this stuff in notes. I'm not gonna make a big whole lesson and redo everything we've already done. So I go right to, I don't put a dot yet, I don't put a point. I then need to take care of my -3 for my rise. Which direction is a negative for a rise? Down, right? Now, don't just think you always stay on the graph on these sheets. Like, don't think I go down just because that stays on the graph. Sometimes you will go off the graph. We said if you go off the graph, you could flip the sign of both numbers. So I could make the top number positive and the bottom number negative, and then I would just go in the opposite direction, but it would still be the same. Still be the same line. So down 3. So there's my second point, and now I just draw a line through that. So be like right here. Not going to worry about making it perfect. That's pretty close. Now I'm going to do the same thing for the second one. You guys try to do it first. I do it. Yeah, we just did. I think the same equation. Start in a different spot, and you don't have a negative in the slope on the second. Give you a minute to do that, and then I'll do it for you so you can check your answer. All right, so what's my first step, Danielle? Say it again. No, wouldn't divide. I'm just graphing it. So there's no math. I mean, unless you're creating a table, but I would just do the, so what's my first, what I do first when I just did that? I have no idea. All right, so you guys need to be writing steps. I mean, we've done it before. If you don't remember it, you need to say step one. Do what? Yeah, step one, you put a point on the y-intercept. So again, if you don't remember what the y-intercept is, you need to write that note. Y-intercept is the number all by itself. Again, only when y is by itself. If y is not by itself, we can't do any of this. You need to make that note also. If y is all by itself, use the y-intercept and the rise and the run. So you need to make, or just go back and look at your notes. We've done this before. So I put a point on -2. Again, it has to be on the y-axis. Do not put it on the x. Some people are still doing that. We graphed not that long ago when we did inequalities. Some people are still putting the point on the x-axis, the left and right, to start. Never goes there. Always goes on the y, the up and down. Now, from there, I need to use rise and run. So, what's my rise and my run numbers? That. Oh, what's my rise and my run numbers? Am I going to call on Kennedy? Welcome back. What's my rise and my run numbers? Yeah. So again, slope gives you your rise and your run. If you need to make these notes, clearly some of you do, right? The slope is the number with the x. I use the slope to get my rise and my run number. Like nobody writes anything down, and then you go back and try to do it. You have no clue. Can't help you if you're not writing stuff down. I'm not going to repeat a whole lesson if you have absolutely no notes. I'll make you search through and find your old notes. Most of you probably threw away. So now I have a rise and a run number. My run is always right because it should always be positive. The only number that should ever be negative would be the top number, unless you need to reverse it so that you stay on the graph. Then you might have a negative rise, I guess, but that wouldn't happen initially. So now my run is 2, 1, 2. My rise is 3, which is positive, so it has to be up. There's that. I go through both of those, which would go through about there. Go. What? That didn't work. This is actually a pretty new projector. I don't know if the board has anything to do with it. But yeah, it is a pain in the butt. Okay, so now we go to there. So there's my second line. What is true about that point where they cross? Logan, what's true about that point where they cross? What's true about that point where they make the X? That's not the point. But what's true about
That's a
that?
solution.
That's the answer. What does that mean? I mean, it's the answer. What does that mean? What's the answer? An answer is the same thing it was since day one. We learned what an answer was. Little difference. What does an answer mean? When I say it's an answer, what does that mean? You shouldn't be doing any math. There's no math.
Oh, no, I know.
So what does it mean when I've told you it's a solution? That's the easy thing to remember. But there will be something that involves a little more understanding, certainly on this quiz. What's that mean that it's a solution? So it's the possible answers to what? If it's on both lines, right? It's on the blue line. but it's also on, that's the only point on both lines, right? No other point, any other point on the blue line is not on the red line. Any other point on the red line is not on the blue line. That is the only point that is on both lines. So what does that mean? It is the answer, it is the solution. That's the easy question to get right on for this, but there will certainly be some understanding stuff on mine as well as the district, I'm sure. What's it mean? What's the coordinate for it first? What's that X and Y value right there? They cross. 2, 1, right? I just go over, I always go left and right first, then up. So 2, that is 2, 1. So what is true about 2, 1? If it's the answer, what's that mean? It's the answer to what? Just. We're so close. So close. This is the only point that exists. Oh, galaxy. That makes this left side equals this right side, and this left side equals that right side. No other point does it. That's why it's the answer. It makes both rules true. I got a whole bunch of rules that make, so this blue line, I got a whole bunch of points that make that bottom equation true. The blue line, every single point on that blue line will make this left side equal that right side. I got a whole bunch of points that'll make this left side equal that left side. That's the red line. I only have one point that works for both. That's why it's the answer. It makes both equations true when I plug it in, meaning that it makes both equations the left side equal the right side. So that's the complete understanding of what a system of equations is. It's the equivalent of, in the last problem, the only solution for honey buns and airheads that made a spin 15 and also buy 8 things was 7 and 1. That's the only thing. No other combination worked. So it's the same concept. It's just we didn't have a word problem behind it to know what this was about, what the 2 and the 1 stand for. We just know it's an X and a Y. All right, so go ahead. You can work if you just want to work on the ones with Y all alone today. That's fine. If you remember how to do the other ones where you make a table of X and Y values, you can work on both of them. And then you need to write the solution. The real final answer needs to be, where do they cross? And that's your final solution. So for this problem number 9, my solution would be, that would be the ultimate answer I'm trying to get to.
Yes.
What is the solution? All right, so go ahead and do that. I'll take attendance and I'll walk around. You got 45 minutes, more than 45 minutes to work on it. So, and then next class, we'll do the same thing again, but we'll focus a little more on the ones where Y is not all that. So. Are there none on my desk? There's those brown things over there for now. If you need something, if you kind of ball it up and crumple it up, it'll soften it up a little bit. And I have some around. I'll have to look for them though. Let's see. Whoa. He's probably going to come over and see what that was. Oh, I'm doing attendance. To attendance, to attendance, to attendance. Oh, stop the recording.